Hey, what's going on, everybody? Happy Thursday. Um, Today's going to be a little longer of a video, but not as much work for you guys today. I didn't want you guys to look at this review. I want you to help prepare yourselves to study because, yes, tomorrow, let me get that out of the way. Tomorrow, we will be taking a quiz for 10, 20, 20 stat and data quiz on eClass. All right, so I'll have directions on the Google Classroom and in eClass. Make sure you go there and take that quiz. Um, if you can't get to it Friday, I'm going to leave it open for a few days. But once you do start that quiz, you will have a limited amount of time to take it. I'll have all the directions there. So best of luck to you guys. Hopefully, you guys can do well. So that's kind of where we're going to start today and what we are going to be covering on the quiz, things that you guys need to know. Um, First things, central tendencies. That's mean, median, mode. Understanding how to find the mean, the average, how to find the median, put them in order, find the middle, and mode, the one that happens the most often. All right. Also, going to focus on spread. All right. How spread out is your data? How consistent is the data? And we've talked about three ways really to look at the spread, being the range, the IQR interquartile range, and the mean absolute deviation we looked at. Um, so being able to find those and making, let me reiterate this. This section right here is really pretty basic math skills, but you got to be able to make determinations and decisions based off those middle terms and how spread out that is. Okay, outside of finding mean, median, mode, and the spread, we need to be able to create box and whiskers, histograms, dot plots, right? Looking at graphs, looking at skews and describing information from those graphs. And then the last piece here, some of you guys have had trouble with. A lot of you guys know what an outlier is, but you need to be able to calculate outliers. I'm going to run through that one more time today in the review. So without further ado, going to get into this review. You guys see on the right hand side, I do have the calculator out. I'm going to show you guys a few little cheat sheets here, or cheat codes, whatever. Some things our calculator can do if you do have access to your TI-84 calculator. Um, it's a great, great tool. So here you go. Top of our review, we were looking at trying to find the measures of central tendency. In case you guys couldn't put this together, you basketball fans, we're looking at playoff points between a couple famous basketball players. We got Michael Jordan, David Robinson, and Charles Barkley here. Uh, and so finding the mean, medians, and mode, and then looking at the measures of spread and range and mean absolute deviation. And so I have already calculated this work here. And so I use my calculator and kind of want to go through this real quick. I'm going to pause so I can get it set up. But I'm going to show you how I do this very quickly in my calculator. All right, here we go. All right, so going to look again. Like I said, told you guys, calculators are great tools. You guys paid a lot of money for it. Hopefully you have it at home. If not, there's some different things available online. Use your phone. But calculating mean, median, mode, all these measures of central tendency, our calculator does a lot of this for us. So look over here on the right. This button right here, stat, we are dealing with statistics. So I can press that stat button. Right? We have to put all of our information into the calculator. And so we're going to build it into a list. So as soon as I press stat, right, we want to hit edit, and it's going to bring up a bunch of lists. Right, in L1, I'm going to put in Michael Jordan's numbers. So bear with me here. We have 22. Enter. 24. Enter. 26. Enter. We have two 28s. So we're going to enter in both of them. All right, I'm going to pause while I enter in the rest of these, and you guys can do the same thing. All right, so I'm going to show you guys what I did. You guys can see here, I started entering in every one of those dots, got put into this list. And if you scroll down, some of the cool things about this calculator, now when you put them in our list, we can make sure we have all of them. There are 18 dots. Notice down here it says L1, 18. That means that was the 18th term. So I have all terms entered my calculator. Once again, I want to remind you guys, I like making these videos. I want to do them more in class if we were in class, because if you didn't understand, please press pause, rewind, watch it again. The steps are all there. Stat, edit, enter in numbers. All right, so next, to find out the means, medians, and modes, going to go back to the calculator here. Remember what kind of math we're doing. We're doing statistics, so I'm going to hit that statistics button. All right, it's in red now. All right, I'm going to scroll over because I've already put the numbers in. I want to calculate, right? All of our central tendencies and so forth are here in the one variable statistics. That's what it stands for. Option 1 should be one var stats, one variable statistics. I just got to hit enter there. Now these newer calculators, I'll ask you some questions. The list that I want to find the statistics isn't L3. I put that in the first list. So I'm going to press second list, right? I want to make sure it's L1. That's list 1, right? L1, right? I don't care about the frequency list. I'm just going to hit enter until it calculates. Now, bunch of numbers here. I'm going to explain some of these numbers. X bar, I tried to say this yesterday. X bar means mean. That's our average. Our average is 30.2, right? Now, here's where we're going to get to with our box and whisker plots. I'm going to save this information for us. But we have our minimum. We have our median. Our middle term should be 31. And our max, 34. It also found our quartiles for us. Remember, those are the middle terms between the middle and the bottom, middle and the top. All right, so very important numbers. The only thing it does not calculate is the mode. All right, so calculating the mode, which bar is the tallest? 32. It should be pretty easy. Right, I did the same thing for David Robinson and Charles Barkley. Um, if I look at those, like I said, the mode for David Robinson, 24, 24, 24 happens the most. And Charles Barkley doesn't have anything repeat, so he has no mode. So go down to these questions. Let me minimize this. Which measure of central tendency would best describe Michael Jordan? Well, let's use that blue. Whoa. Here we go. We got our pin back. Michael Jordan. Let's look. Look at that data. Most of it is over here. And what are those points doing? That is going to take our mean and move our mean to the left. It's going to skew our data. So if I want to pick the best one, I don't think that the mean, even the fairly close, I don't think the mean is the best. I think most of his data is there around 31, 32. So I'm going to pick the median. Why? Because it's skewed to the left. The middle term, 31, really represents to me what is best. So remember, this is a big question in why. Right, so we'll talk about David Robinson. Looking at David Robinson, you can tell, hey, they're all the same. It doesn't really matter. You can use any of those central tendencies, and I think you can come up with a reason why. There's no real outlier, right? Everything's really close, very consistent. Um, so they're all the same number. Pick any of them. But now, when it comes to Charles Barkley, right? Interesting. We only have 5 games, but look at that number 59. I can look right now and say, hey, that doesn't really match. He had one really good game, but look what it does to our mean. Look how much higher our mean is. It has pulled that mean away from the middle. And so I definitely would not pick the mean for Charles Barkley, but I would pick the median. Cool. All right. So I'm going to do this because we're going to need this information for the next set of questions. We're going to take a picture of our work here for the range because I have calculated the range. Let's cut that. And boom. All right, so we're looking here, already calculated range of the biggest term minus the smallest term. Look how much Charles Barkley spread apart versus David Robinson's very close. Michael Jordan, more games, but still fairly consistent, but not as consistent as David Robinson, right? But then I did calculate the mean absolute deviation, right, using those tables. I said our calculator does not do that for us, but we found the distance each point was from the mean. So I'm going to take each data point and subtract that from the mean and then find the data points or find the mean of those, right? Once again, what we did yesterday, go back and look at that. So reviewing Charles Barkley's scores, it appears there might be an outlier. Which score would be an outlier? Well, the only one that doesn't fit would be that 59 of his, right? So what does that outlier do to his average? It moves the average higher because it moved it to the right than the median. Outliers are going to move the means away from the median. So knowing this, would you use the mean to describe it? No, I wouldn't. So, right, question number 5. Comparing the mean absolute deviation of each player. Which player had the largest mean absolute deviation? Well, Charles Barkley did. What does that mean about him? He is not consistent. Right? He had one game where he scored 59 points, but the rest of them, he didn't score as many. And so that mean absolute deviation, that 9.6, says that he can, on average, he's scoring 35 points, but he can also score 10 points higher than that, 10 points lower than that. We don't know. Where we look down here at question number 6, who had the smallest mean absolute deviation? Well, that was David Robinson. And so what that tells us is that mean absolute deviation 1.2 is he is very consistent. No matter what happens, we know that he's going to be around 24 points. On average, each game, he was within a point or 1.2 points of scoring 24 points. All right, so those are the determinations you guys will have to make. All right, so I'm going back here to look. If you flip that paper over, we had to create some box and whisker plots. Right, so this is where I have my calculator pulled up again. I do have this information put in for Michael Jordan here. Remember, our calculator will do this. It'll tell us our mins, our Q1, our Q2, which is the median, the Q3, and the max. Right, these are the key 5 points we need to make a box and whisker plot. Right, Once again, pause the video, make sure yours are correct. But I'm going to draw a box in Wesker plot for Michael Jordan. His minimum, 22. I put all those points on here. Q1, lower quartile would be 28. Median is 31. Q3 is 32. It's the upper quartile. And his maximum is 34. So, median, Q1, Q3, that makes up my box. I'm going to connect the box to the min and max with a line. So if you look at Michael Jordan's scoring right here, you can tell that most of his points were in between that 30 or that 28 to 32 inside of that with that IQR, right? We scored a lot. Most of his points were there towards the right-hand side, but he did have a couple games where he did not do so well. All right, so let's compare that to David Robinson. Let me change the color to green. David Robinson had a minimum of 21. 22.5, 24, 25.5, and 27. So look at his box. Really small, really consistent. All right, but he didn't have the upper end scoring that Michael Jordan had. Although he was very consistent, you knew what he was doing, still didn't score as many points. But then we'll go up here to Charles Barkley. Barkley. We had a minimum 20 points. He had the least. Q1 is 25.5. Middle term, 32. 46 was Q3. And 59 was his max. So if you look at his box, boom, not a very consistent shooter. He was all over the map. Half the time he was down here, half the time he was up here. Right, he did have some points down here, but he did have potential to go score a lot of points. You know, I don't know who you're picking to be on your team for the NBA Finals. If you said Charles Barkley because he might be able to score, I get you. But I'm going to pick Michael Jordan because he is consistently higher. Right, so using your box and whisker plots to make that decision. Cool. So scroll down here. Going to fill in this information for you guys for all three players. All right, so back looking at some of the stuff, trying to calculate outliers or what will be an outlier. The first thing I need to do is go and find the IQR so you can see my calculator. I took Q3, subtracted Q1. I found the IQR of each data set. Now, take those IQRs, like for Michael Jordan 4, and multiply it by 1.5. Michael Jordan has an IQR times 1.5 is, that should be our magical number 6. David Robinson's magic number 3 times 1.5 should be 4.5. And Charles Barkley should be 20.5 times 1.5, which that magical boundary number that we're going to use is 30.75. All right, so using that information to find the lower boundary, you're going to do this work in red. The lower boundary, take Q1, and I am going to subtract that number. So any points that are below, let me move that out of the way. Any points that are below 20 2 will be considered an outlier. Same thing here with David Robinson. Take Q1, which is 22.5. I'm going to subtract that magical number, 4.5. And anything that's below 18 would be an outlier. Same thing with Charles Barkley. We have 25.5. I'm going to subtract 30.75. And so just for fun, we're going to do it anyways. You can't have a negative number in basketball scoring, but to be an outlier would have to be negative 5.25. Cool. So we found the boundaries. Now let's go back and look at those that information. Are there any outliers? Well, Charles Barkley doesn't have any. David Robinson doesn't have any values below 21. But Michael Jordan, lower outlier boundary of 22, that is the same number. And so it doesn't fall outside of that boundary. And so it is not an outlier. So in green here, let's look at the upper end. All right, so take Q3, 32, and this time we're going to go above that number. So I'm going to add that same number, 38 would be an outlier. For David Robinson, 25.5 is Q3. So I'm going to add, 4.5. So 25.5 plus 4.5. Is there anything over 30? Nope. And for Charles Barkley, let's look at that big number, 46. So we're going to add 30.75 mathematically. Do we have an outlier? 46 plus 30.75. He would have to score 76.75 points to be an outlier. I know 59 looked like it, but mathematically, there is no outliers. We don't have any outliers in any of that data. So give yours a check, look at your work, compare it to mine. All right, so once again, going to take a look here, frequency tables and histograms. I'm going to pause it to fill in the data. You guys can check your answers. All right, looking at my frequency table, I counted up all of my red, yellow, green, blue M&Ms, all right, and I created a histogram, a bar chart. All of my bars have to touch. They need to look equal, right? There can't be any gaps. So I had 12, 3, 4, 3, and we can look here. And so describing the shape, when I look at this, if I look, most of my information here is on the left. So yes, I would say that it is skewed to the, it's pointed to the right, All right, so the M&M factory states that each bag is randomly assigned colors. Using what you know about the shape of the data, do you believe them? Well, I don't, because obviously most of them are red in this bag. So I would say they are definitely skewed to have more red M&Ms. All right, dot plots. Check it out. You guys can see my answers. All right, so created these dot plots. Looking here, that first dot plot, we have that perfect pyramid. It is not skewed, it is symmetric. Whereas the middle one, we do have most of our data down here on the left-hand side. So it is skewed to the right. Because remember, that tail is going to move our mean. And then the last one, it is symmetric, but it is also uniform. All right, so what does this mean about our mean? Well, if it's symmetrical, then our mean and median should be the same. But if it's skewed to the right, that means that our mean, remember, is going to get pulled away, is going to be greater than our median. And if it's uniformed, they should be the same again. So which measure of central tendency would you use? Well, mean, we normally stick to. I wouldn't use my mean here, I'd use median. And then in the last one here, I think you could, probably the median here, because that middle term is really going to tell us which one is the center. All right, so I think you guys can understand and read histograms, how many presidents were from 50 to 54. Well, 4 of them. How many presidents were from 40 to 44? Only 2. And how many presidents 60, or how many more presidents were 60 to 40? That is 4 versus 45 to 49. That was 1. So there were 3 more presidents. I hope you guys can handle that part. Looking at box plots again, estimating, we need to look at 2 different plots to make some decisions. What's the difference between the medians here? Well, what do you think the median is for Tammy? I would say 26 versus Emma, who has about, what is that, 34? So what is the difference between the medians? I would say 8. Whose number of emails per day is more consistent? These are the questions that I worry about for you guys. Look at how wide that IQR is. All right. Even though they might have more emails, who is more consistent? I would say Emma, because her IQR is smaller. 50% of her emails happen inside of here. All right, develop an argument as to why Emma receives more emails. Well, if you look, hey, 50% of the time she's getting more. She's getting more emails here on this end. Remember, 50% of her data falls above that median. So, all right, guys, there's the answers. Use that to help you guys. I think tomorrow's quiz should be fairly easy. Like I said, the instructions will be posted. Do the best you can, and we'll readjust and reassess and see what we need to do after we take that quiz. All right, good luck.